Hi everyone, today we are diving into the buffer overflow attack using the Seedlabs environment. First, download, we need to extract it so that we can observe two files are in the lab seed folder, that is code shell, terminal, and we can observe the stack seed with the vulnerability of string copy function. So we string copy vulnerability because it does not check the boundaries, allowing us overflow override the written address on the stack, which means instruction pointers to point our malicious shell code that we can rewrite the root of the program. So the goal of the level 1 is to masters the fundamentals of hijacking the instruction pointer. In this we have a here with file. So in that we need to replace the shell with our 32 bits file. In the shell code we can find the code for 32 bit. We need to copy this and paste it in the exploit .py file, and to run this we need to disable ASLR and staggered with the command. So this command is used to disable the address base layout recommendation that is by setting it zero memory static. So address is found in the, so by using this command we are changing the secure shell that is dash to dash to execute the exploit .py to find the buffer size and pointer values. We can go to gdb terminal by using the command. So here we can find the vulnerability of the stack. So here we can find vulnerability stack, and to find the pointers value we can use the command. These are the pointer values. For the offset value we need to difference between. Here we go to offset value of 108, and we will use this offset value in the exploit.py by you increasing the offset value of 108. And we will use this offset value and extract increasing it to 4 bytes, and the return address will be the change return address. We can increase it to overcome the stack value to execute our shell code. Now we are going to run the exploit.py file, and we need to run the out stack our stack. Here we also need to change our start point because we have to overcome the return address, and start point should not be the low, and we will return it again. So we have to overcome, and here we can verify it by, so the UID is 0 and we have to root access. So this is level 1. And next, similarly for level 2, the goal is to learn how succeed when you don't know the exact buffer size. So we will almost apply all the logic, but we have no idea to the buffer size. So here we make all small changes in the exploit.py .py file that the we have no idea for the buffer. So we comment out the start point, and remaining values are almost same. We comment out the offset because we don't know about the buffer set, so we know very well run this file. So here we successfully overcome the level 2, and we can verify it by same method, and we have the root access. So for level 3, the primary code is overcome the null byte constant of 64th bit. So for level 1 and 2 we mostly used 32 bit. So here we will use the 64 bit. So using the same method we replace the 32 bit shell code with the 64 shell bit. So we will take 64 bit. So using the same method, we replace 32-bit code with the 64-bit shell. 570, which is the exact bytes of the bad file minus length of the shell code, and we will make some changes in offset. And as it is 64-bit, we will make the L equal to 8, and this value change based on the output. Now we will run the file here again, and the level 3 is successfully completed. We can verify it and have the root access for level 4. The level 4 goal is to execute an attack when the buffer is too small to hold the payload. That is, the buffer is tiny. For example, 10 bits you can't fit a shell code inside a bit hole. So for that, we made small changes in the return address and that offset based on the goal of level 4. So we can see the root of the success and overcome the run. Achievement of all goals 4 levels. Thank you.